First of all, good morning, and congratulations for making it to day 3 of the conference. It's always tricky. There's so many great talks at conferences like NDC that I know by day 3, sometimes the brain can be getting a little full. So thank you very much for choosing to come to my talk this morning. There's some other great options, so I really appreciate that. This morning we're going to be talking about designing for change with vertical slice architecture. Now, this is a talk I've wanted to give for quite a while, but I've always shied away from an architectural talk. I always think I'm not clever enough to be talking about this stuff, you know, with the likes of Martin Fowler, Sam Newman, people like that. Who am I to talk about architecture? But at the end of the day, I've been doing this for 2 decades and, you know, I've seen quite a few things and I seem to have noticed quite a few patterns along the way. So I thought, time to man up and actually get out there and get this talk done. So to just set the scene for this is very much coming from my experience over the last 20 years. Things that I've seen working on various different types of application at various different types of companies, various different industries. And I think it has been quite an interesting change in the way I think about building software. So hopefully by the end of this, some of you at least will find it interesting, hopefully, and no one will fall asleep. So, before we kind of get into everything, let me just quickly introduce myself. My name is Chris. I'm a software engineer at Enable. I'm an MVP. I've written a book, and I do some open source work as well. I just want to take a little second here, though, to have a call out to Enable. We actually achieved something pretty amazing at the end of last year, and some of my colleagues are actually here in the audience, including my manager, so you all need to be very, very nice to me for the rest of this talk. But we actually managed to close a Series D at the end of last year, and we actually got a £1 billion plus valuation and officially became a unicorn, which obviously in the current market is quite a difficult thing to do. So it's more a case of just saying that it's not all doom and gloom out there. There are still good things happening in tech. So I just want to get that out there. The other reason I want to mention Enable is because some of the things I'm going to be talking about today actually tie very closely with what we're doing at Enable right now. So, with all that said, let's get into things. And I want to start by talking about change. I think it's fair to say that change is probably the one constant in our industry. There's always something changing. And that's kind of the joy of what we do, isn't it? I mean, there's always something new to learn, something new to try out. Arguably, it's also probably the biggest curse of our industry because there's always something new to learn and there's always something new to try out. Now, when it comes to designing software, often we talk about this stuff as engineers. Okay? We talk about the technologies that we're going to use, the frameworks and libraries that we're going to use, the patterns and practices that we're going to use. And these are obviously great things to be talking about, and absolutely we should be talking about them when we're designing our applications. You know, how do we create good abstractions so that we're not tied into a particular technology? How do we make sure that we can swap out libraries if we need to? That kind of thing. But what I've realized as I've gone through my career is that the biggest source of change in what we do with our software is in the requirements of the business, the requirements of the customers. Now, interestingly, when it comes to designing software, weirdly, this topic doesn't get talked about a huge amount. Obviously, we talk about what features we need to build, and we think about how, you know, we should pick technologies based on those things. But what I hear less discussion about is what happens if those requirements change? What happens if the business focus shifts and we need to change tack about how we approach things? Would the software be able to flex with that? Would it be able to change? And really that's what I'm getting at with this talk. This is going to be the theme as we go through, is building software that changes for requirements more so than technology. Because what I've found over the years is that while it's great to be able to potentially swap out your database for another one or a library for another one, the reality is that doesn't actually happen very often. Whereas requirements are changing every week. So I want to start us off with where I started my career, with N-tier architecture. I started my career as a software engineer, sort of late 90s, early 2000s, and this was the dominant architecture. Arguably, it's still one of the most popular. It's still used by a lot of applications out there. Now, I'm sure most of you have seen this type of diagram before. We have a user interface, a business logic layer, and a data access layer. And when I started my career, this made a lot of sense. It seemed a good way of organising applications. I started at a time as well where you didn't kind of do much with a database as a software engineer. You had these people called DBAs, and you sent scripts to them, and then they sent emails back telling you how wrong you were and how much you were going to ruin their database, and you would ask for forgiveness and make all the changes, and hopefully they would run your script on their servers at some point. So this was good and it made sense, but as I got a few years into my career, I started noticing that this was, I don't know, it felt a little clumsy, things got a little bit messy. And around sort of 2008, Jeffrey Palermo coined the term onion architecture. And the major shift here was that instead of the data store, the database being kind of the base layer of your architecture that it is in N-tier, we put the domain model at the center. Now, this is a concept from domain-driven design, which was from Eric Evans in 2003. It's a very interesting book, and I'm a very big fan of domain-driven design. So when I saw this architecture, it really spoke to me. It made a lot of sense. I was like, well, yeah, of course, the center of our architecture should revolve around the business that we're modeling or the particular area that we're serving. And over the years, this matured. This was a time where there's a lot of different type of architectures coming out. There was another very popular one around this time, which was hexagonal architecture, which has the concept of ports and adapters. But everything kind of culminated around 2012 with the clean architecture from Bob Martin. And what he was doing here is taking all of these various type of architectures that had came out over the last few years and kind of trying to create an architecture that incorporated the best of all of them. But again, the key thing here is we've still got the kind of business rules, the business entities at the center of it. So if we just kind of go back, I'm going to use the N-tier architecture for the majority of this talk as the example, because to be honest with you, it doesn't really matter which one of these I particularly pick. So if we use the N-tier version, when we're designing applications, we kind of have these groupings with layers. We have kind of two ways of grouping, in fact. We have the horizontal, which is by technical responsibility, so user interface, business logic, data access, or user interface, application services, domain, whatever you want to call it. And then we have a secondary grouping, and this is usually by an entity, okay? So as the example here is for a fictional repair system, we have a repair, and that's serviced by a repair service in a repository, a job by a job service, and an engineer by an engineer service, and so on. And then there's some UI that calls into those things. Or maybe there's an API. It all depends. So this looks nice and neat and tidy, and this looks great as a design. Very clean, very tidy. If we drill down into the services a little bit, you'll see methods like this. And again, these make perfect sense. We have methods on there to get open repairs or completed repairs or all engineers or some engineer and things like this. And again, this all makes sense. This all is neat and tidy. And especially either in the design phase or the early stages of an application. If we zoom out a little bit and look back at our layers in a bit more of an abstract sense, we have these lovely code paths. Again, it looks very neat and tidy. It makes a lot of sense. We have some UI. It talks to a service to do with an entity. That talks to a repository. And that's all good. And there might be some other things in here as well, but that's I'm kind of going for a slightly more general sort of view at the moment. And at this point, when we're designing applications, we kind of sit back and we're all really happy with ourselves. We look at the design, it makes sense, everyone's using it, it's perfect, right? All makes a lot of sense. And we start developing the app and everything is good. But the problem is, there's this pesky problem called commercial pressures. And they really affect the shape of an application over time. And that's another key point about the talk today. I'm not talking about applications in their first year, in their first 18 months. I'm talking about an application that's 2, 3, 4 years into its life cycle. Because most architectures are great in the first year. Kind of almost doesn't really matter what you pick. But I'm interested in what happens further down the line. So what's the effect of these commercial pressures on our applications? Well, first of all, you will probably have rushed features. I'm curious to ask, actually, how many people here have had to rush a feature? for some reason. Wow, look at that. Okay, so there's all kinds of reasons this happens, right? Classic one, you get the sales guy, just landed this great contract. The only problem is, you know that feature that you said you needed to build that was going to take 6 months? I'm going to need it next week, right? That's one thing. It might be all other kinds of reasons. Customers are going to churn and things like this, right? It could be that we've promised something to somebody, all these kinds of things. But it all ends up with the same way. Rush features, and what does that mean? We cut corners. We have to. We've got to find that time from somewhere. So maybe we miss off a test or two. Maybe we just reuse that bit of code. It's not really reusable, but it's close enough, right? It will get us over the line. The next thing, custom functionality. Now, this all depends on the type of application you're building. Now, most of my career has been building sort of line of business applications, B2B systems type stuff like that. Let's have another show of hands. Who's had to build a custom piece of functionality for a particular customer at some point? Yeah, most of you again. You get to write that lovely bit of code, don't you? If customer equals A, then do this, otherwise do this, right? It's glorious, isn't it? We all feel really, really great about ourselves when we do that. And again, same reason. Customer comes along, big bag of cash. Can you just make it do this for me, right? And of course, it's a business. We're there to make money after all. So of course, we say yes. But now we've got compromises in our code. Okay, now we've got code paths that are only for a specific customer in a specific scenario. And then, of course, the fun one, technical debt and refactoring, or rather the lack of. Because when you're trying to rush features out the door, build custom functionality, get all your other commitments done, you're going to be accruing tech debt probably, certainly in the rush features example. Of course, you need to do some refactoring, but you can't do that because, again, you're up against the clock, you're trying to get these things out. So, of course, the first thing that goes is that. We've all been in the meeting, I'm sure, with a PO that's like, I really need you to help me get this thing done. And we're like, yeah, of course, we'll do that, but you will give us time to refactor, won't you? Right? Now, when you compound these things over time, put in there as well a growing software team, in my experience at least, layered architectures always end up with the same problems. The first one is they always become more complex. Now, arguably, you could say this about any software system over time. But layered architectures get complex in bad ways. They get complex because they become harder to maintain. As we add more features and ultimately we have to make those little compromises here and there, the system gets harder and harder for us to maintain. The testing might be getting more lax. We might have dropped testing altogether because it's become too difficult. And finally, they become harder to learn. A system in its early stages might only take a new engineer a few days to get up to speed in order to be, self-reliant and can work on their own. Then it goes to days. Then it goes to weeks. Then it goes to months. I could actually talk about this specifically at Enable. We have actually been tackling this very problem ourselves. We have had a system that's been developed over many years. It's got complex. And we got to a point where we're having engineers take multiple weeks and breaking into months in order to become truly self-reliant and capable of building features on their own. This is a real problem. And really, I'd sum all this up, bringing this back to change, is let's just become harder to change. The more of these compromises we make, the harder it is to change things. So why? Why does this happen? Well, in my opinion, I can boil this down to one single word: coupling. Without fail, every system that I have seen get to the point of being unmaintainable, end of life, replaced by another one, it's always come down to the same problem: coupling. Specifically, high coupling. Now, I feel this usually has a root in one single place as well. And a little bit of a warning here, because anybody who has worked with me knows my feeling on this, but I really hate services. Services have been the #1 problem in every single system I've worked on. Now, I'm not saying that these things can't be made to work, I'm just saying that the majority of the time they don't. And that's not because theoretically they can't work, it's because of the realities of building software. And that's, again, what I care about. I care about the real world of building software, not just the theory. And really that's because with these services, they always end up having high coupling and low cohesion, which is, I'm pretty sure, the exact opposite of what we tend to try and achieve for maintainable software. So why does this happen? Well, we all looked at our lovely, neat and tidy repair system earlier. Well, let's pretend that we fast forwarded a few years and we've had a few of those commercial pressures, we've had a few new engineers. So what does things look like now? Well, our services have grown. They've grown a lot. We've got all these different types of method in there now for all different manner of things, right? Because this is what we've encouraged in the architecture. We've grouped things by an entity. Therefore, if you're dealing with that entity, you put the method in that service. I'm intrigued as well. How many people here have had services that are hundreds of lines long? Cool. 1,000 lines long. 2,500. Still hands. I know there'll be a hand for this at least, because I'm looking at some of my colleagues over here. 5,000. Yeah. It's more common than we believe. These massive services happen all the time. The other problem, with this service is single responsibility principle. A class should have one reason to change. Do we think that's got one reason to change? How can something have one reason to change when we've got 5,000 lines of code in it? I mean, that'd be a really good reason. There's more problems. I don't know if any of you would have spotted this before, but I'm going to help out. Do these methods look a problem to anybody? Look very similar, don't they? Now, the other interesting thing is they're dealing with two entities. Which service do we put it in? Getting repairs by engineer, I can probably get on board with that. That makes sense. I'm getting a repair, I'm just using an engineer as the filter. But get repairs for an engineer? Yeah, I'm not sure. Maybe they're returning different shaped objects, I don't know. I'd have to go into the implementation to find out. I never would though, because there's no chance I'd be running these services side by side comparing method names, because I'd be too busy trying to get my feature built. The other fun thing is I am going to let you in on this. I did actually work on a repair system, so again, some of these things might actually be real examples I'm giving you. And I will plead the fifth of whether we did have a repairs engineer service or an engineer repair service, or both. These fun things do happen. There is yet more problems here. Let's have a look at these methods. Now, it might not be the case, but I will put money on it that the getEngineerLike method is calling the getEngineer method and just ignoring some of the properties, right? And again, I may or may not have written this method. But again, this happens all the time. And this is that shortcut that we took to get that feature done under those rushed circumstances, because I only need a subset of that information, so that's all I'm going to use. No, there's a method that already does that for me. I can save a few minutes by doing that. Let's zoom out a little bit and have a look what our neat little diagram was of all our system calls before. Yeah, it's not looking so pretty now, is it? This is what happens after time. Everything starts to call everything, and this is that coupling. All aspects of the system are essentially linked to all other areas in some way, shape, or form. At this point, we'll probably be noticing some problems. So, if you don't track a metric called cost per feature, I'd really encourage you to start thinking about it. I'm not a huge fan of metrics and tracking for engineers. I think it can get used in a bad way, but this one is a very, very good one. Because as an engineer, you can use it to work out the state and the health of your application. If this is trending upwards, you've got a problem. It's either that your system is becoming more complex, it's becoming harder to maintain, it's becoming harder to learn. We're going to be probably noticing a rising bug count at this point. We all saw that mesh of calls. How do you know the effect of a change you're making? You're going to have to almost have every part of your application in your head at once. Performance issues. It's going to be another issue we're probably going to be seeing. Those overfetching that we saw with the engineer and the engineer-like method. Those sort of things will compound over time. Again, we've probably not got optimal code paths, things like that. So performance is probably going to start being an issue, let alone the ability to scale parts of the application independently. And really what I'm describing here is that we have got a big ball of mud. And this is really where we end up most of the time. More recently, I also heard this described as a lasagna, which I actually think is great, although it does make me feel very hungry because I do like lasagna. But yeah, messy layers. I think it's a fairly decent analogy. So, what is the problem here? Well, one thing that's perplexed me for a while is that we don't build software in layers. It's not how we do it. Again, I'll ask you, has anyone ever had anyone come to them and say, PO, PM, whatever, could you build me a data access layer? How about a business logic layer? Not the kind of request we get, is it? What we get instead are, I've got a user who needs to manage their engineers. Can you give me a screen where they can filter engineers by trade, by area? That's what we get asked to do. And that's not layers. That's traversing all of the layers. It's just more in a slice. We can see where this is going now, can't we? So is there a better way? Well, I think there's a better way. And this is something that I discovered. And the moment I saw it, it just made total sense to me. And interestingly, it's from a fellow speaker here, from a guy called Jimmy Bogard. Now, Jimmy has produced a lot of interesting open source packages over the years and given lots to the community. And he's also a very good architect. And this talk really changed the way I thought about building software. So, of course, I'm talking about vertical slice architecture. So, the question at this point is, well, what is vertical slice architecture? It's interesting because really I'd probably sum it up in this way, and I would say that vertical slice architecture is essentially organizing by use cases and not technical responsibility. That's how I would sum this up as concisely as I could. And this feels like the right way to go about building software, because ultimately our systems are made up of use cases. It doesn't matter whether it's an API-based application or a UI-based application or a CLI-based application. They all have use cases, they have features, they have capabilities. And that's what we're doing in vertical slice architecture. We're organizing around that and optimizing for that. So what does that look like? Well, if we take our end-tier architecture or our layers and think about the way that we group things here by technical responsibility, a vertical slice architecture looks more like this. And what we do is we create folders based on the capabilities of the system. Now, I'm going to assume most of you are probably dealing with .NET because we're at an NDC conference. So this is probably a project with a folder called features or use cases or capabilities, whatever you want to pick. And then under that, there is just going to be a list of folders that list out the capabilities of your system. And then within each of those folders, you are going to put the mechanisms for delivering that feature. It might be some UI, it might be some logic, it might be some data access. It might not be. Like I say, you might not have a UI to your application, so it might just be some logic, some data. It could be that you don't even have data because that particular feature is just going to put an event on an event broker or a message on a queue or something like that. And that's kind of another important thing, and we'll talk about this a little bit later. It's all about building the feature in the best possible way, not having to traverse through layers for the sake of it. Now, I'm going to talk about something that I know always brings up feelings when I'm speaking to engineers. So I'm going to borrow a phrase from an old work colleague. She was Italian and she used to always say brace, brace when she was about to deliver some contentious news. I'm going to duck for this one. We don't share code between verticals and vertical slice. In fact, we try not to share code at all. Now, the reason I say that, and I joke about the reaction, is because I've observed an interesting behavior. I've introduced vertical slice to multiple teams across multiple companies. And interestingly, almost without fail, the first question has been, how do I share code? Now, I think that's a very, very interesting mindset that we have, that our first reaction is, how do I share code? We don't know if code can be shared. We don't even know what we're building yet. We're just talking about a general architecture. Why do we think about code sharing first? Interestingly, my view on this is that code sharing is probably one of the most dangerous things that you do as a software engineer. We put it on this pedestal as the ultimate goal of good software is sharing code. We talk about it all the time. Interestingly, though, that's what led to this. Doesn't look like good code to me. So why does that happen? Well, most of the time, I truly believe this comes down to the fact that we don't truly understand what should be shared. We overshare. Quite a lot of the time, what we share isn't actually shareable. It's similar. And we'll talk about this in more detail later. But for now, and I do this with everybody who I kind of talk to for the first time about vertical slice, we will work on the basis that we just don't share code. And that is what keeps these nice, clean verticals that we have. And that does allow us to achieve a key principle in good software engineering, which is low coupling and high cohesion, the exact opposite of what we saw from the layered approach. Low coupling is obviously good because what that means is we can change parts of our system independently. This is good. We can change our system. And high cohesion is good because that means that things that change together live together, and that's surely got to be good from a developer productivity standpoint, right? What I don't have to do in a vertical slice architecture is spend a hunk of time going around trolling through all the various services that I need to troll through to find the odd method that this particular code path is using, and understand all of those things and all of the side effects they have and all of the other things that are calling into them to make my change to hope that I don't break something. Another key tenet with vertical slice architecture is coding for what you know. Now, I wasn't sure how to put this because I've kind of played around with this slide far more than I would like to admit. Because I put things like, keep it simple or code for simplicity or go for the simplest answer. And the reality is, and like I said, I want to keep this very much grounded in the real world of what happens with software, is that sometimes the answer isn't simple. Sometimes we have a complex problem and it needs a complex solution. So it's not about writing simple code or complex code. But what it is about is writing code that you know. And really what I'm getting at here is essentially things like premature optimization, okay? Coding for what-ifs. That has, again, led to many a problem in the systems I've been on, as people going ahead and coding for things just in case. I'm going to put this abstraction in just in case because then I can change this thing. Don't know what I'm going to change it to, don't know why I'd change it, but I'll put it in anyway. Oh, we might want to do this other thing in the future, so if I just put this bit of code in here now, then that'll make that easier. Again, we don't know what that will look like, so we don't know if that way of doing things, if that particular abstraction is actually going to be the right way of doing things. And what I've found over the years is that essentially it's far cheaper to have some duplication in the system than it is to have the wrong abstraction. I worked on a system very early in my career where some abstractions were put in place that quite literally crippled the system in later years. They were wrong, completely wrong, and ultimately they led to the death of the system because it became unable to change. So what would be a far better way to do things is to build things for what we know right now, but have an architecture that allows us to change it later when we know more. Kind of ties in with a bit of the whole Agile approach to things. Build something now, iterate on it. As we learn more, build for that. Another great thing I like about vertical slice architecture is essentially the ability to design each feature optimally. So what do I mean by that? Well, when we're dealing with a layered architecture, the way we work is kind of set. We've got these layers we need to traverse and these things that we need to use, and that's what we do to deliver a particular feature. But wouldn't it be so much better if essentially we could almost architect each feature independently and build the best thing that it needs? So starting on the left, if we've got a simple use case, and these are slightly contrived, so bear with me, but if we've got a simple use case for a CRUD operation, right, some CRUD UI, and we can just have something that just takes that information, chucks it in a database, some simple validation, whatever. That's all we need to build. Why build anything else? Perhaps we have some UI and has a handler for that puts a message on a queue or an event on an event bus. Cool, let's just do that. Or perhaps we've got an application, a worker service, something like that, and it's just going to consume some messages from something like Kafka, and it's going to write some data into a database for shadow copying or something like that. Again, just do it, job done. Or perhaps an API application, endpoint, handler, chuck something in a DB, fires off a domain event, something like that. Cool, done. What we're not stuck is working through artificial layers for the sake of it because they just happen to be set by somebody 5 years ago who's probably not there anymore. So, what about developer productivity? I would say that vertical slice architecture has probably been the most productive architecture I've used and with the teams that I've worked with. We at Enable have used a layered architecture previously, and we've actually just been building a new product called Claims, and that has used vertical slice architecture. We've been able to do something that we've not done before. We've actually been able to get the application out to early access clients. We've been able to get feedback ahead of our go live launch, and we've been able to make changes to that application in order to better suit our customers. And that has been partly due to the fact that we've taken a vertical slice architecture approach. We've been able to build features very rapidly, try them out, and if we don't like them, we can essentially just throw them away and recreate them and not have side effects on the rest of our system. So I'll talk about that a little bit more in a second, but one of the other key things I think from a developer standpoint with vertical slice architecture is that it's also been much easier to learn. And why is it more easy to learn? Well, if we obviously think back to our mesh of calls in our layered architecture, if we're trying to understand a feature and make a change, then we've got to go to various places across the system, okay? As things have changed over time, our kind of code paths have spread out as well. So I've got to understand all these different areas in order to make a change because there's this coupling that we mentioned earlier. So that means that I've got, as I said earlier, I keep a lot of the system in my head. And there's an interesting book I read last year from Mark Seaman called Code That Fits in Your Head. And it's an really interesting book. And it talks about the idea that there's kind of been studies shown that really, as humans, we can only really keep 7 concepts in our head at any one time. And what I found is that in this style of architecture, you get to 7 concepts pretty quickly. And that makes stuff very hard to keep straight. If we kind of compare that with a vertical slice architecture, it's a bit of a different game. Because we don't have that code sharing and therefore we don't have that coupling, if I want to go and say work on feature F, and I'm a new engineer to the team, I actually only need to care about what's going on in feature F. And we've got that high cohesion, we've got all of the things together in one place for that particular feature, so I've not got to go off finding things across various different projects and of various different abstractions. Now, if you have a look at the clean architecture templates that you see online, it's quite interesting that a template without any business logic has anywhere between 8 and 12 projects in it, and can have anywhere between sort of 15 to 40 files before I've even started. That seems an interesting way to go about doing things. And that's all in the name of these abstractions. That's putting these things in place so we can change things easier and all of that. Well, how about if we don't do that? How about if we just build the features like this? And coming back to the learning side of things, as I go through my time at the company, I'm going to touch more features, and I'm basically learning the application in stages, and this is a lot easier to digest. Another interesting trait of vertical slice architecture is that it becomes much easier to separate. So if we think about a system as a monolith, and I just want to be clear, I have no problems with monoliths. I don't think monoliths are bad. Ironically, I think a lot of the bad press about monoliths is actually more the layers that they're using than the actual monolithic approach themselves. Monoliths are very productive ways to build software quickly. But with the best will in the world, even with the most conscientious engineers and everything, if you are doing well, there will come a point where you might need to scale parts of the application independently. Now, with vertical slice, this is a simpler process because we have these features, they're isolated. We can essentially pull out the features that we need to scale and essentially put them into a separate process, whatever that looks like for that particular application. Another web app, another worker process, whatever it happens to be. And that's because we don't have this coupling between the various layers of our application. Now, I do want to call out something here in case people are wondering. I have sidestepped a little bit of a landmine in that I'm not talking about databases here. And I'm aware of that, and I've made a conscious choice to do that. And that is because it's hard. No, it's because ultimately it really does depend how you're storing your data. If you're storing your data in, say, like a document database, it's probably going to be easier to pull apart than it is in a relational database. But it's already going to depend on your particular application. I think it's slightly irrelevant to the point, though, because ultimately I've got to pull the database apart whether I'm using a layered architecture or I'm using a vertical slice architecture, except with a vertical slice architecture, I also don't have to pull apart all the code paths as well. So however you look at it, it's still got to be easier when you're using verticals. Another thing I really like about building applications with vertical slice architecture is that I actually spend the majority of your time writing new code. And who doesn't like writing new code? New code is far more fun. We don't have to understand what's already there before we make changes. We can just get on with doing what we want to do. And a good example of this, again, is something that we've actually done with our claims product, in that we had a feature, we had a way that we thought it was going to work, and we were looking for feedback on it. And what we realized is that the feature was good, but the implementation wasn't quite right. So what the engineering teams could actually do in this instance was actually just build V2 right alongside the existing one. We don't have to touch the existing code. By the time we changed it, we were changing 80% of the current implementation anyway, so we just wrote it from new. Separate folder. If you want to as well, if you're kind of A/B testing, you can easily A/B test at this point. You can use feature flags to do that. But the really cool bit is when you realize that you don't need version 1 anymore, and then you have to do the cleanup, and it's as simple as hitting delete on the folder. And boom, you are done. You're not having to wade through all of your various services and everything like that in order to pick the code out and check nothing, reference it, nothing. Right-click folder, delete, done. As I said, you can also build, like say, different versions of features alongside each other really rapidly, see which one sticks. It's good. It's a very, very powerful tool to have. Now, let's come back to those lovely commercial pressures. What do they look like when we're dealing with a vertical slice approach? Well, obviously they still affect things. There's no way that they're not going to. But for me, a vertical slice architecture can cope with them far better. So the first thing that we talked about was rushed features. Now, when we rush features in a layered architecture, we make compromises in our code. We have things like that engineer light method we saw before. We might miss a bit of testing here and there. We might write some questionable code in order to get things done with the time frame that we have. Now, in vertical slice, we obviously aren't going to have the engineer and engineer light method problem, right? What you might do, though, is if you do have the get engineer version, which is the full thing, you can copy that code, paste it into your new feature, and then just delete the bits you don't need. Almost as quick, still get the same result. That's one thing. But let's pretend that you still have to do horrible, hacky stuff. The key difference here is it's contained to the feature. It doesn't bleed into the rest of the system. When you make those hacky bits of code to get these things done, they're contained in a box. And that box can't reach out and touch anything else. And that's a key difference, because if we're going to write bad code, let's at least keep it contained. The problem is in layers, it can easily spread and sprawl. So in that way, I think we kind of create a bit of a shield around that in some regards with verticals. The next one that we had was custom code. So what about custom code? Well, with custom code, what we can actually do instead is just write a whole new vertical for that particular use case. And we can have it alongside the existing one. So we don't pollute the existing code with if customer this, if customer that. We just have two different versions of how that thing should work. Now, at some point, you obviously are going to still have to write that lovely if customer X do Y thing. But now it's probably much higher up in your stack in the API or in the UI potentially, depending on how you're organizing things. And it's just basically sending down two different code paths for those two different features. Still not ideal, but I still feel that's a little bit better than what we would do in a layered approach. And then the final one was tech debt and refactoring. So, if we're accruing this tech debt, okay, and we've sort of said already with verticals, yeah, we're still going to do that, but it's better now because at least it's contained. When it comes to the refactoring side, yes, if you're having time taken away from you for doing refactoring, which again, that's probably still going to happen. It's the business that controls that. But when you do get some time, it's going to be easier to do the refactoring because you're not refactoring so many things. With the layers and all those mesh of calls, you've got to understand everything before you do your refactor and make sure that you understand that the change you make can't break anything. That takes more time. But with the vertical, because things are contained, you can refactor things quicker and easier because you know there's no side effects. It's literally just what you've got there. Usually as well, and I haven't kind of said this explicitly, but testing in vertical slice tends to be a lot easier as well. Again, because you just don't have so many dependencies. You don't have so many couplings. So I want to sort of talk now a little bit about CQRS. Now, other people, and if anyone's looked at vertical slice before, you've probably seen this comparison. Interestingly, vertical slice was not where I started to use CQRS. That was actually, ironically, when I was building applications with clean architecture. And I did this because, as we all know now, I don't like services, right? So my way of getting rid of services was to actually start using CQRS. Now, just quickly, if anyone's unsure, CQRS, command, query, responsibility, segregation. And essentially what we're doing here is modeling actions in our system in terms of commands, which are things that mutate state, so inserts, updates, deletes, and queries that read state. Okay, and really everything you do in your system kind of falls in one of these two buckets. And again, this is something that when I found it, it kind of made a lot of sense. Now, CQRS often gets put in a bucket with event sourcing, which is kind of where you go all the way down and sort of separate out your DB into optimized reads and optimized writes. You don't have to do that. Okay, you can do this purely at an application level. You don't have to then go all the way down. It's what kept me away from it for quite a while because I always thought that I had to do all of this, and that sounded very complicated, and I'm not smart enough for that. So once I realized this, I thought this is a much better way than using services because we can have these commands and queries, and they will stop this sprawl and stop this massive service, stop these massive services with thousands of lines of code in them. And they did. They absolutely did. And I just want to be clear on that they definitely helped with some of those problems inside of the layered approach. It didn't solve the problem of the coupling, though. Because ultimately what we still tried to do was write reusable generic queries and commands that we use throughout our system. And ultimately that created the coupling that we had before. So it was better, but it still didn't quite cure the problem. But this pattern works very, very well with vertical slice. So this is really something I sort of was really happy to see. and I carried it over. Now, I also want to be clear, you do not have to use CQRS with vertical slice. You can build the code out within your verticals however you feel is best, whatever way you like doing it, all right? There's no right or wrong there. But I'm just saying this is an approach I found that's very, very good. Interestingly, I was in Sam Newman's talk on Wednesday, and I also agree with something he said, because he was talking about how words are very important. And I've always disliked the idea of like command. It sounds very brutal. And he actually said almost exactly the same thing, and he uses the term request, and that's actually ironically what I had also picked. So every now and then, it's always nice to you get something right when someone as smart as Sam Newman is doing it as well. So I often use the term request, and ultimately I like that, because ultimately everything we're doing in the system is some form of request, right? We're requesting data, or we're requesting something to be saved, or we're requesting for a message to go on a queue, or something like that. So if we think now about what this looks like within a vertical, it kind of ends up being modeled like this. So we would have an area of our application, and we will be defining the capability. So in this case, we're going to view an engineer, right? Load an engineer's profile. So we would have a request for that, and C# records are great for doing this. So you can have a view engineer request that's taking the engineer ID that we want to view, and then that is passed off to a handler. Now, the handler is going to be a class that has a method that takes in that request, and then within that method is where you're going to do the work to fulfill that request. So in this case, I'm going to go off to the database, I'm going to bring back the engineer, and then I'm going to return a response. I want to stop at this point as well before anyone, because not so much for you, I'm sure you're all thinking this as well, but this is going to go on YouTube. Yes, there is potentially a null reference exception in there. I get that. I know some of you were thinking it, all right? Yes, obviously single or default could return a null, all right? But I didn't have a lot of space on the slide, all right? So let's just all acknowledge that, YouTube people. I'm going to look at the camera over there now. I get it. You don't need to fill the comments with that. Now, a key point here is that, remember, we're within a vertical. The response that we're returning is going to be modeled absolutely perfectly for how it's going to be used. And what I mean by that is that when you're reusing things in layered systems, you end up usually having things not quite right. You might have to make additional requests to get a bit of information, like you get an ID back, so now you need to make a request to get a friendly name or things like that. What we're going to do here is optimize perfectly for the use case. So if we've got a screen that's going to be displaying the engineer profile, this response will be everything that screen needs to display in the way it needs to display it. Okay? If we have name divided by, split up as first name and surname, we can push them together at this point, so the UI or whatever doesn't need to do anything, right? We can tailor it specifically for its use case. So ultimately, that response then goes back to wherever it was dispatched from, and then we are going to do what we're going to do. And hopefully that code's going to be fairly simple, because we've been able to tailor the data payload to how that is going to be used. Now, if some of you have done any CQRS work before, you again are probably thinking, doesn't that look just like Mediator? And of course it does look just like Mediator. I actually didn't realize Mediator was a thing, and I started doing this manually, and then that was when I was doing clean architecture. And then when I saw Jimmy's talk on vertical slice and he talked about Mediator, I felt pretty stupid that I hadn't looked for something that did this on it already. But Mediator does exactly what I've just shown you. So instead of having to write a load of middleware and bits and bobs to wire up these requests with handlers, Mediator is going to do all that for you. You register, essentially give it an assembly to scan, and it's going to look for things that implement like an iRequest, and then you've got an iRequest handler, and it joins everything up and makes everything nice. It's also got some other cool things. It's essentially like a bit like a pipeline, so it's a bit like .NET middleware, where you can do some bits before a request and after a request and everything. So again, you don't have to use it, but it's definitely something that is quite useful, and and hopefully would save you a bit of time. Okay, right, let's come back to this. Now, as I said, when I start people off with vertical slice architecture, I always say to them, don't share code. And the reason I say that, and I'm very, very strict on this, is because I want to break that mindset. I think as engineers, like I say, we get drilled into us about code sharing, right? The dry principle. That principle has been the bane of my existence to some degree. And that's because we kind of almost try to find it, right? We're looking for it, right? Instead of what I think the other way around, that we should be doing this, is letting it come to us. That's what I think the correct way should be about sharing code. So it's probably worth defining what makes code shareable. And I thought this would make a great slide. So of course, what I did was go off to the internet and I had a little look around for some smarter people than me to define what this meant. And I came up with quite literally 0. I cannot find anywhere that gives a clear definition of what makes code shareable, which I find is really interesting in an industry that promotes code sharing as such a massive thing. Then why can't we have a clear definition of what code sharing is? Now, I'm sure if I asked all of you, you would all have an opinion about what that looks like, right? It would probably be something like, oh, it's got the same behavior, it does the same thing, right? And I agree. But it's interesting that no one's formally kind of done this. We kind of like doing this as an industry. We like having these nice, clear, concise explanations of things sometimes. But we don't seem to have one for this, which is interesting. But I'll take a stab and say some characteristics that I would look for in shareable code is, first of all, it's got to take the same inputs. If it takes inputs, it might not do, right? But if it does, they should be exactly the same. It should also, therefore, have the same output, right? And that means the same shape data, right? Obviously, I didn't put this down, I probably should have done, it's a given it should be doing the same thing, right? It should have the same behavior. I hope that we would all agree that. But the big one for me is that it should have one reason to change. Because this is where I feel the difference is between code that is the same and is shareable and code that is similar and gets shared. Because what we will often do is say, well, this code is pretty much the same, so I'll share it. But really, it's got more than one reason to change, which means if it's got more than one reason to change, chances are at some point those reasons will diverge and you will end up with some code that now needs to do 2 different things, but it's used by 2 different places. And then you have to rely on the fact that you'll be able to refactor those things, undo that coupling, and sort out that mess. And that's, as we've already talked about, something that not always happens, right? Another thing when it comes to code sharing is I would always use the rule of 3. Now, if you've not heard of the rule of 3, this was from Martin Fowler in one of his refactoring books, which are great books. But what we're saying here is, and I want to try and read this out properly, is you're allowed to copy and paste the code once, but when the same code is replicated 3 times, it should be extracted to a new procedure. And this kind of is a good rule for me, because if you copy code once, that's actually not that bad. If we think about what I said earlier about the cost of the wrong abstraction and essentially the cost of coupling, it's actually still cheaper to have the same bit of code duplicated twice than it is necessary to create a coupling when you're not sure if that's exactly right. But by the time you get to 3 replications, you can be pretty sure that that's a good bit of code to be refactored. So this is something, again, I would really encourage you to think about in terms of when you're sharing code. Wait and see if there is actually 3 versions of it. I will just give one slight little anecdote here, interestingly, is when I was actually working with a team recently talking about vertical slicing, they were trying some ideas out. And they said, Chris, I know you said we can't share code between verticals, but we are absolutely sure we've got a good reason to do it. And I was like, okay, cool, let's talk about it. And in this particular method, they were doing a bit of logic, but it basically came down to the fact that there was a fairly meaty entity framework query that was doing some work. Now, like, we don't want to have to duplicate that, that would be bad. I was like, okay, cool. So it's got the same input, right? Well, yeah, pretty much. Okay. Same output. Yeah, pretty much. All right, and it's doing the same thing. Yeah, pretty much. I mean, it does. They have different where clauses. Okay, but it seems like they have different reasons to change them. How do you trigger that? Well, we send in a Boolean. Okay, so let's just agree that that's not shareable code. They're doing 2 different things, and we should just have 2 separate code paths. Yeah, and then that probably makes sense. So let's pretend that we have agreed that we do actually genuinely have some shareable code. How do we deal with that in vertical slice? Because although I've been hard-lined on this now, of course, we don't want to duplicate code for the sake of it. If we do have shareable code, of course we want to be able to share it. So, first of all, standard refactoring techniques, right? and extension methods are a great way of sharing code, right? They're a nice way to group things. They're usually extremely easy to test because they're completely stateless most of the time. And they're also very easy to deal with when your application needs to break apart. If we need to tear a chunk off and scale it independently, and obviously it's using these extension methods, there's multiple approaches we can take, right? We can copy the extension method into both places. We can also refactor out to a shared project, or we can also go whole hog and create a NuGet package and use that from 2 different places, right? So it's very easy to keep the kind of manage that coupling. The next one is refactoring to functions. Now, I'll hold my hand up. This is probably terribly worded, right? I cannot think of a good way to describe this. And I didn't want to have another rant about services, but really what this says is don't use services. And what I mean by that is don't go and create a service to share code, right? Because we all know where that's going to end up. Instead, create objects that do specific tasks and do one thing. Keep single responsibility principle in mind. So, as an example, don't go and create a billing service because that's going to be a dumping ground for anything to do with billing. Create a billing processor with a single method on it that's public called send invoice, and it takes in the repair that it's going to bill, and that's it. That's all it does. That's its one job, and it has one reason to change, and that's because the logic of changing how we send invoices changes. Right? Aim for that kind of refactoring. Don't aim for generic classes because they will always end up going the same way and becoming those big dumping grounds. Now, the final way that you can manage sharing code in verticals is by using a domain model. Okay? Now, I mentioned earlier on, I'm a big fan of domain-driven design. I think it's a great way of modeling businesses and designing applications to serve those businesses. And a domain model works really well with vertical slice, right? Largely, this is where we should be sharing things, right? Because if these are business rules, if this is the way the business operates, then we should be fine to model these in our code because, again, we've got one reason to change because the business changes, right? So if we've got verticals that are relying on aggregates and entities in a domain model and they change because the way the business work changes and therefore, you know, we have some issues and we need to make some changes in those verticals, well, that's the right kind of change, right? That's the right time for the coupling to cause some problems because the business has changed and we need to change the software to model that, right? So there's definitely a form of coupling we're introducing with domain models, but it's, in my opinion, the right type of coupling. Cool. So that is about all I've got for you today. I just want to say, I hope this has been interesting. I hope I might not, if you're a layered architecture person and you've not heard vertical slice, hopefully I've given you some interesting things to think about at least. And if nothing else, don't use services. Okay? That's all I ask. But thank you very much for your time this morning. Enjoy the rest of the conference and have safe trips home. Thank you.